Good afternoon, everybody. And I must really want to applaud Mr. Bhullar for giving us, a very big insight about all the legal aspects and what all are the, the sections under which these aspects can be covered. So I'm Dr. Arpite. I am Associate Director from India Cellular and Electronics Association. And our association is basically the apex industry body for the mobile and electronics industry, which has several verticals in it, bifurcated as IoT specialization, then agricultural electronics would be there, then electric vehicle segments is there. So with respect to that, I'm here for giving a very brief and a very short presentation on the storage systems and the EVs. So EVs and energy storage, basically, if we come to say, they work together. The growth in the EV market has its own implications in the energy grid. Now here, the presentation is basically all about how these two are interconnected. The storage systems and the EVs. How are they going to be benefited from one another? So electric grid basically faces a challenge to support the extra amount of generation to support the EV segment. Then energy storage for EV has some notable synergies with certain constraints, limitations, then opportunities as well as the challenges that come along with it. So the driver here can be the cost of the EV batteries are basically reduced. Okay, so it's here. Yeah. So drivers can be basically reducing the cost of EV batteries. Now, how is this going to be a driver here? Once the manufacturing increases, automatically the production is increased at a much more faster pace, and henceforth all the technologies incorporated, they also mature with time, and henceforth the cost of the EV batteries would reduce over a certain duration of period. The restraining factor here would be the lack of charging infrastructure, as rightly pointed out by Mr. Bhullar in his presentation also. This is one of the factors, concerning factors here, in which the EV charging infrastructure at places needs to be defined and standardized. So challenge also here is basically the standardization of the EV infrastructure for charging. Then opportunity would be the government initiatives that are pertaining to the establishment and further adoption of EVs, in which the PLI has come in, then the EPOs, RPOs and ESOs, they have come into place by the Ministry of Power, stating that how much obligation should be there for consumption of renewable energy for the charging of these infrastructure, the EV infrastructure. Then a more responsive, controlled grid infrastructure with a decentralized energy generation mode, which could support the EV, would be a very good combination if we can go and look into when we are facing high peak demands, and when there are control issues of the segment, then and other drivers which basically hinders the easy adoption of electric vehicles into this segment. So all of this, these four factors, they add as well as give us certain points which we need to put our focus to drive this segment. Next, please. Then EV and energy storage market interactions. How is this? EVs are connected to the grid. Then emergencies in terms of supply shortages and supply to the power grid. This happens when there is a high peak demand, and this could be one of the constraints which we face if there is a real high surcharge in which you need to supply the powers. So we'll come in the later slides, I'll try and explain that how this can also be looked into. Then proliferation of EVs lead to economies of scale. We all know that. There are policies, various policies that the government have released for the adoption of EVs into this segment. And better monitoring, control, communications, better computer algorithms in the electric vehicles itself make it much of a compatible vehicle, and henceforth simultaneously parallel approach also follows for the infrastructure as well. EVs and storage, they complement, and it drives the battery market. This is the base here which we need to understand. With the release of the PLI, it was basically the development of the battery manufacturing technologies here. So how was it supposedly going to benefit this segment? because once the technology is developed, automatically they would be, developing much of a better battery storage capacities, and henceforth this is going to increase in terms of the EV proliferation in the market. Secondary, which comes to just the adoption, would be the usage of the secondary cells that come from these particular batteries itself. That would be the secondary storage systems which come from these particular batteries only once they reach the end of life. Energy storage will basically play a very important role in responding to the challenges that arise due to the EV charging due to the on-peak hours. This I just explained before, so this would be one of the challenges that we would face. We are all aware of the general storage system types. The very prominent one here is the lithium-ion batteries, very commonly used in cell phones, laptops. You have to move to the next slide, please. Next, yeah. Then we all are aware why is it mass used? It is basically due to the high energy. The relative electrical energy storage systems are better in terms of the lithium-ion batteries. Higher energy efficiency is there, good temperature performance, and low self-discharge is there. So concerns here basically would be a relatively high cost as of now, if we can say, but over a period of time this would go down. Then high temperature performance and low self-discharge. Nickel metal hydride batteries, they are specifically used in high-end computers and the medical equipments, which require a specific energy and specific power capabilities which cannot hinder over a period of time. So stability is one of the important criteria here, which is supported by this particular mode of batteries. Concerns here again are the high cost, the self-discharge, and the heat generation that is a part and parcel of this particular battery segment. Lead-acid batteries, a very common mode and very common segment, and we all can see it through common transportation modes in the form of e-rickshaws and all. They still use that, but then also it has a very low specific energy and a very cold temperature performance, a very rugged one, and reliability is one of the major factors here. Ultracapacitors, energy is stored in between the liquid, that is between the electrodes and the electrolyte, and when the surface area basically increases, so henceforth the energy storage capacity also does increase with that. So this can actually, give an extra amount of charge in which a vehicle is climbing a hill or something, then and even if it is coming down, then you have to high braking power. So the additional amount of power can be supported by the ultracapacitors. And concerns here, we shouldn't say as a concern, but basically they have the a secondary mode of help which can, either accelerate or deaccelerate in a particular vehicle. Next slide, please. Growing importance of energy storage. There are two methodologies here. One is V2G, and the other one I was talking about is basically the stationary energy storage system. Stationary energy storage system uses those particular batteries which have actually reached the end of life, which are used in the electric vehicles, and henceforth now can be used as a stationary power. Best example can be, if we've heard the previous sessions as well. So one was the very welcoming factor, that was the solar power usage. So in that case, for the energy storage, the solar energy can be used in places where the EV charging infrastructure already exists, and henceforth that stored energy can be utilized in charging of the EV vehicles, which would be giving less burden to the actual grid connected to give the supply to us. So, next slide, please. The EV batteries and the energy storage advantages is there. Cost efficiency, how? So it all goes back to the manufacturing segment. If battery manufacturing increases with a better technology input, automatically the cost is decreased, and henceforth the efficiency increases. Carbon footprint, more manufacturing. Here we have to understand that yes, manufacturing also adds to the carbon footprint, but if we are using the same battery in its second mode of life, you can say, if we can stop saying end of life, we should say another second life cycle of that particular battery, it automatically would reduce the footprints. The financial incentives that are given by the government to support the adoption as well as the battery manufacturing in terms of the technology additions, then the metal usage in this, various forms that can be incentivized. Supply security, yes, one of the major criteria. Why? Because if we are using this particular supply in terms of the high peak demand hours, it will disrupt the whole of the grid system. It can. Possibly it can if the grid connections vary, or if the charge that you are trying to withdraw from it, that varies. So in that case, DDGs come, that is the decentralized distributed generation modes, but that also has one of the limitations, or the limiting factors you can say here, is the availability first. That is the form of the renewable energy that is available at that particular area or the region, likewise solar, wind, whatever is available. Then all the parameters that follow when this particular DDG is connected to the grid. Because these systems are not stabilized in their own manner, so henceforth when they are connected to the central grid, there are variations into the connections, and that has to be restrained, because if that happens, whole of the grid can fail. So that is one of the most important factors. Supply security, energy systems, definitely a plus point, but then proper conditioning has to be done. Circular economy. Last session also, this was a major point. This is one of the most important criteria here. What happens when any of the segment of whatever parts you're using in EV, they reach the end of life? Circular economy plays a major role here. And in that case, be it any part of the EV or the battery, they have to be recycled. All the products, likewise metals or any other electrical parts, they have to be reused. That is the mode of circular economy. How much can be generated in the form of waste and how much can be reused? So that is the technique you need to understand and follow, because if you have one mode that, okay, this is waste for us, so you need to understand how you can utilize this waste, and that comes in the concept of circular economy. Next slide, please. DDGs I've already explained, so this is nothing but a very generalized concept. Whatever is available at that particular location, you can use it. The Consolidated Energy Storage Roadmap, as shown by the India Smart Grid, this is also available on the Ministry of Power website. So this shows the projection. Where are we right now? Then by 2032, how are we looking at the total energy storage demand in gigawatt hours? So that is resulting into 2146 gigawatt hours with the support of stationary storage as well as the electric vehicles. That is V2G part. Next slide, please. ACC. Next slide. Next. Next. Okay. PLI on the advanced chemistry cells, we are aware of this. Government had approved the 18,000 crore PLI for the ACC manufacturing here in India. It needs to support 50 gigawatt of domestic cell manufacturing, the advanced cell manufacturing. So features, cash subsidy on output or volume that are manufactured, higher performance cells that also can be used to avail the incentives, and the subsidy benchmarks, raising the quality and the performance bars. Then 3 companies have already signed for this, being Reliance New Energy, Ola Electric, and Rajesh Exports. And basically, other partners also, apart from these, the private players, they also are expected to create capacity roughly around 95 gigawatts. This will basically favor the ecosystem in both the generation part, the manufacturing part, and the recycling part. So it goes in a complete loop. Whether it is an open loop or a closed loop, that's a different issue. Open loop basically means that once any part of EVs is dismantled, they are recycled, it goes for some other segment utilization apart from that EVs, and closed loop can be utilized to manufacture another set of electric vehicles, depending on whatever matter has been recycled. So next slide, please. Coming to the end, nutshell, basically it says we need to define the mode of energy storage. Whichever is favorable, that should be considered. In terms of the generation, transmission, and distribution assets, DISCOMs here play a major role. When we see RPOs and ESOs, that is energy storage obligation, we've already discussed about this. 85% has to be from the RES, renewable energy sources. Till then, I don't think so. This would actually solve the purpose also, why are we doing this? So obligation, the ESOs plays a major role here in this. And evolution of policies over the time, they expect to improve the performance and decrease the cost of all the added parts that are used for making an electric vehicle. Then a grid map, as we've already seen, it has to be channelized, basically, to enable a good consumer participation here, a good renewable energy integration as well, and connectivity of the grids, smart grids, microgrids, and the central grid connectivity to support this challenge when the extra energy demand supply is prevailing. And obviously, we know the PLI schemes for ACCs, then automotive sector as well, and the FAME that was initially released. These schemes, as well as all the schemes that are going to come up in future, they are definitely going to play a major role here, in which you need to bridge the EV systems as well as the secondary storage systems. So that's it. Thank you from my side. Thank you so much.